our next speaker from Twitter. He's very active and in the tech community. I know some people have mentioned to you that they saw him do a talk just last night at Manhattan.js, I think on Rust. Is that right? So he's versatile. He is an icon in the industry. I'm very happy to welcome to Ember NYC, Steve Klabnik.
Hi everyone, I'm Steve. Oh, that's loud. Also, even with doing 1 million presentations a year, my computer is actually screwed up. Can I borrow yours? Awesome.
2 nights in a row?
I'm 2 nights in a row. The internet, it won't connect. It's Wi-Fi. So I use Linux. Yesterday, my Linux worked perfectly, except multiple monitors. Today, multiple monitors, fine. Wi-Fi, no. So, yeah, this is why most people use real computers, but I'm one of those hippies that like hates closed source stuff, so what are you gonna do? Cool. Everything is broken all the time in computers, which is actually a good introduction to JSON API. Segue. JSON API is something that's very special to me because one of the things JSON API is me destroying one of my programming heroes. A very long time ago, I mean this is still technically true, but also a long time ago it was true. I used to be like a little Yehuda fanboy. Like when I was starting in Ruby, I was like, man, Yehuda Katz is like the coolest Ruby programmer. Him and Aaron Patterson are like these two amazing programmers. They know so much about everything. You know, I am not worthy to read their code. You know, all that kind of ridiculous things that you do when you like think that someone is really great. And I'm not saying that Yehuda is not great, but when at a conference called Mountain West Ruby Conference a couple years ago, Yehuda pulled me aside and he was like, hey, so I hear you're into this weird hypermedia thing. I think that's bullshit. And we proceeded to argue for like 4 hours in front of a bunch of other people, like over lunch. This is like an hour before lunch, and then lunch happened, and then after lunch. And at the end of it, he was like, okay, I think that maybe you might be see, computers, they don't work. At the end of it, he was kind of like, I think that you might be right. I need to see some code, but like, I'm willing to accede your position. And I was like, ha, Yehuda doesn't know anything. I am an amazing programmer, and like, whatever, right? And so and this is why I actually think that like programming celebrity is bullshit, because none of us know how to make computers work, and you know, this stuff happens all the freaking time, right? Like, I literally have a Ruby tattooed on my body, and I have commit to Ruby on Rails, and I like opened an issue on Rails the other day about something stupid, and it was like, yep, expected behavior closed almost instantly. So we're all just trying to figure out what the hell is going on. So JSON API, more specifically. So that conversation eventually ended up becoming JSON API, because one of the things that Yehuda was thinking about at that point in time was like, you know, obviously a lot of the lessons that Ember has built have come out of the experiences of Rails and Yehuda working on Rails. And so you can feel a whole lot of Rails inside of Ember. How many people are Ruby people versus not Ruby people here, by the way? Just so I don't make the wrong assumptions. Ruby people? Okay, most people are Ruby people. Cool. It's also cool that there are non-Ruby people here as well. I like to joke that I'm a New York JavaScript fanboy, in that like I literally know next to nothing about JavaScript, but I love going to New York JavaScript meetups. I was at the first Manhattan.js ever, and I didn't even live in New York at the time. I just happened to be in town, and I went to it because New York JavaScript people were great. But anyway, back to JSON API and Rails and stuff. So Rails' lessons led to Ember, and therefore historically, Ember and Rails have played really nicely together, or at least that's what I'm told. And the problem is that if Ember had just been the Rails JavaScript framework, it never would have really picked up and moved on. And it's not really fair to privilege Rails over other kinds of back-end technologies, because, you know, other people do like other programming languages than Ruby for good reasons. And so we don't want to exclude them from the awesomeness that is Ember, right? So you need to have a mechanism by which these like front-end applications can be back-end agnostic, right? Because that's the whole freaking point. If it just worked with just Ruby stuff on the back end, it would be dumb, no matter how good Ember is. And with that in mind, Yehuda was trying to figure out at the time, how do we make this back end agnostic? And so I was advocating. It works.
It's JSONAPI.org.
Oh, cool. See? Computers. Interestingly enough, it was actually donated to us. That was really rad. Yeah, we couldn't get the .com, but we got the .org, so that's cool. Awesome. Whoa. So, anyway, so the idea that I was advocating for is specifically, I said, what needs to happen is, you have this boundary, right? Like lots of good software design principles are about enforcing boundaries in your system. Object-oriented programming is theoretically about modularizing your program by introducing object boundaries, and those boundaries interact with each other. And you have interfaces between those boundaries, right? This is like dependency injection, for example. You have a strong interface, you swap out a real implementation for the fake implementation. You saw this with the VCR idea, right? And so lots of programming is about creating boundaries, enforcing boundaries, mixing boundaries into giant balls of mud, and those kinds of things. So the idea then turned into, we need to demarcate the boundary between where Ember stops and where Rails starts, and that way we can swap out Rails and swap in something else. This is like a really freaking old basic computer science idea. It's not super complicated. But where that boundary actually lies is the network requests, right? Because that's how your front end talks to your back end. So my position that I advocated and that Yehuda eventually accepted, actually unbeknownst to me, this is also a funny story, I'll get to that in a second, but was that we would create a standard completely independent of Ember or Rails, and that way you could swap out either side of these things. So for example, my last job at Balance Payments, we had a Python backend, but we used an Ember front end. And so by using the JSON API spec for our API, we were able to like make that work out relatively easily because it did not necessarily have to be Rails. So the funny part, the second funny story I have about the history of JSON API as a thing is that like I didn't even know that I had won this argument because I mean I knew I had won and that you had agreed this was a good idea, but I was about to get on a plane like internationally somewhere, flying for like 10 hours, and then I see this tweet like, check out what Steve and I just made at JSONAPI.org, and I was like, oh, cool. And he like wrote up the first draft of the spec and just kind of posted it without even telling me he was going to do so, because he was at a conference and somebody had like worked on it with him and he got real jazzed and just posted it. That was really cool, but I was trying to like answer questions. People were like, what is this? And I was like, it's a thing. And like reading the spec really quick so I could like actually answer questions. We've gotten a little bit better about it since then, but the initial release, which is about a year ago, a little over a year ago, was a little hectic. So anyways, that's the idea. And so I'm advocating for JSON API even broader outside of Ember and outside of Rails. And the reason for this is because of bike shedding. So this is actually, let's see if the internet works. I'll tempt the internet gods once more. This is one of my favorite things. If you Google image search, so I was doing a talk about this stuff, and I went on to Google Images. I'll Google image search for Google image search. That's great. So I did a Google image search for bike shed, okay? And then this is the first photo that comes up for bike shed, and I was like, that doesn't look like a bike shed. And then I went, oh, god damn it. Right? Because that's like literally the act of bike shedding over whether or not this looks enough like a bike shed. But this is the thing, and the real name of the bike shedding principle is Parkinson's law of triviality. And what it actually means, bike shedding is not actually a value statement. What bike shedding means is there's an inverse proportion between the ease of getting introduced to something and how like complicated that thing is. So like it's easier to argue over the name of a variable than it is to argue about a giant refactor of an entire subsystem, because it's just simpler to fully understand the variable naming as opposed to the refactoring. So naturally less people will want to argue over the refactoring and more people will want to argue over the naming because of its like ease and or trivialness. So we, as programmers, have this weird thing where we like to argue about stuff on the internet, and I don't fully understand it even though I do it myself. And so we will argue endlessly about the most trivial bullshit that does not matter at all. Like, in terms of delivering client value, whether or not you use camel case or underscored names in your JSON keys means nothing. It is completely irrelevant. But you know and I know that we will argue passionately about that for days and like go home and drink after we lose that argument, right? Like, it's like the most important thing to us in the world. And so, when I think about, like, again, when I think about Ember, I think about it as taking the good things from Rails, taking its lessons, extracting them, and then applying them in a new domain. And so, this is what I was thinking about JSON API as well. If the great lesson of Rails is convention over configuration means you don't spend time bike shedding over pointless bullshit, then we should have a JSON API standard that gives you conventions so you don't have to argue over trivial bullshit. And so that's kind of the broad general idea behind JSON API and why I'm advocating for its usage even outside of Ember and outside of Rails, because I think that it would be much better if we spent time arguing about things that did matter, you know, like Go versus Rails versus Node, as opposed to that's such a better argument, right? Anyway, in the spirit of trolling, by the way, our logo is not valid JSON, if you notice. That's also a deliberate, hilarious choice. It looks a lot worse with the quotes, but it's like, I love it that it's not actually valid JSON. It's wonderful. So this is kind of the background, and this is the idea, and so this is why I think this is important. So, and this is why I would encourage you to look into where the spec is right now, see what it is, and argue with me and Dan. Dan Gebhardt has also been helping out a tremendous amount with JSON API. He actually did like the impossible and did a whole like unified theory of physics kind of deal, but on JSON API. So out of this argument, we like, when Yehuda and I first put this thing together, there was like two styles. One was the hypermedia style with links that was like my baby, and the other one was the ID style that was just whatever, which is the like transitioning Rails people over into using this thing. And so they were kind of like two specs in one. And Dan not only managed to unify those styles, but then actually unify the semantics of everything with this really elegant, every operation maps to a HTTP patch on a single document kind of like awesomeness. So Dan has been super great in terms of helping. So the three of us now are kind of in charge of building the spec. So there's all that stuff. There's at least one more thing I wanted to say before I actually showed you some samples. I guess we'll just get to it. It's fine. All right. So the other aspect that's difficult, I should say this is probably part of what it is. The other aspect that's difficult about building a spec that's agnostic, in an earlier presentation someone pointed out like, oh hey, it's problematic when you're uploading bulk record uploads because then you need to say that like none of them fail, right? And so one of the weird things that we've come across and been talking to people about the way these APIs work is that if you can't make certain assumptions, then certain kinds of decisions are very hard. So there was an argument for a while over whether, for example, a single thing should be wrapped in an array or not, because it's easier to process if it's always an array, but it adds 2 more bytes and looks kind of dumb if you know it's going to be singular but has an array in it. So you can kind of like go back and forth about these kinds of things. But the point is that like we made all these arguments so you don't have to. Last thing, I did remember what I'm going to say about the very last thing before I show you some of this stuff, and I'll give you an overview of the basic idea of what it looks like in a second. But there's been a number of different JSON formats that have come out, not recently exactly, but that exist. So you could choose HAL, for example, is a very popular format for like designing how to build your API. There's collection plus JSON, there's Siren, there's like a whole bunch of other things like this. And the thing that makes JSON API different is what I like to jokingly call the materialist versus idealist approach to API design, which really pissed the HAL guy off a lot. But if you're vaguely familiar with materialism versus idealism in philosophy, the terrible 2-second overview is that idealism imagines there's a perfect universe that exists separately from ours, and that ours is like an imperfect projection of that universe. So like somewhere out there's this other thing that exists. And materialism kind of asserts that there is no other thing at all. This happens with like the mind-body problem with like, do you have a mind that exists independently of your body, all this other kind of bullshit. And so the way that we designed JSON API was that we said, we don't want to imagine in an abstract, non-existent world what your API should look like, and then design a spec and then try to force our imperfect world onto that. The first iteration of the JSON API spec was literally just like, what does Rails do by default if you ran Rails G resource whatever? And so we started from that position and then slowly figured out where the weird edges were and refined it, because if it's closer to the thing you're already doing, you are more likely to use it and you are more likely to understand it. So I actually don't think this is the optimal way of building an API in like if I was going to go from nothing and like create from whole cloth a specific thing. But I do think that it's damn good anyways, and frankly my arguments are mega pedantic because I'm an HTTP nerd. And so they sort of kind of don't really matter. And so like I think that this spec is a really great formalization of what Rails does as a server by default anyway. And so it should feel relatively familiar to you all because it's not that different from what you had been doing with maybe a couple of tweaks. So that's also sort of the guiding philosophy too. And when we make changes to the spec, which I'll mention in a second, as we've refined and changed the spec, we have always privileged existing implementations and running code over theoretical nerd HTTP, but RFC 2616 says arguments, which I'm the one making those, so I can make fun of those people, because that's like me. And so we've always tried to keep it like, you know, what are people doing in the real world? How does that work? And then feed that back into the spec as well. I have been mentioning the spec is changing. I just merged a week or so ago, something like this, 1.0 RC1 version of the spec. So it is very, very, very solid. There are only a couple of teeny tiny little things that we need to sort of figure out before it's like 1.0 good for realsies. And like I said, my previous employer balanced their computers fall asleep while they're presenting all the time. I don't know what's going on. And they use JSON API, like I said, on the server side for doing all of their API stuff. It's actually the API they expose to the external world. And they're currently pushing over $1 million a day of credit card transactions like through that API. So if it's good enough for production ready use for that, if you're not doing something that intense, then it's probably good enough for whatever thing it is that you're doing. Not to denigrate what you're doing, I'm just saying that like this is used in real situations. I didn't like make this up and I'm trying to get you to use it for nobody's thing. I actually hate credit card transactions. That's a whole nother story. You should have seen me after Manhattan.js last night. We were out drinking in the financial district. I literally have a copy of Karl Marx's Capital One in my bag right now. So you can imagine what being drunk in the financial district is like, Steve. All right, so with all that background shenanigans, I want to show you a little tiny bit of the overview of the format so that you can kind of get a vague feel. I'm not going to go through the entire spec because that's silly and boring and no one wants to hear that. But I kind of want to show you the like basics of how this works. And we put examples in the spec, and I hope it's a really readable spec. So I decided rather than generate a bunch of slides that would just be the spec's text, I would just show you the spec. And then if they're confusing, I can fix it or something. All right, so basically what it boils down to is we only have 3 reserved words at the top level of an API response. And that's meta and links and linked. Everything else is kind of your data. So in the most simple sense, if you're just trying to, we use a blog post. It's actually DHH's blog, making fun of him kind of, as the examples in the spec. So if you have a blog post, then you have a JSON object, and you have posts, and then you have a JSON object, and it's got your data in it. Cool. Like, this is like the most basic thing, right? But the funny part about this is that a lot of these small decisions actually matter later. So for example, this is like one of those classic bike shedding arguments that happens when you're building APIs, is like, do I namespace this stuff under posts, or do I not namespace this stuff under posts? And you all at least know a little bit of JavaScript, so you know that you don't just return an array because bad things can happen if you return a JSON response with an array at the root. And if you didn't know that, now you do. There's actually a security thing where, because JavaScript is silly, you can override the array constructor and then bad things will happen. You can Google that later. But you can't just return an array, so you have to at least wrap it in a JSON object at the root. And then from there, it's like, do I namespace this or not? So you could just be like data and put some crap in there. But we actually namespace all of the things under the name of the collection, and that will matter later. And in the simple case, a post is just represented by its ID. So in this case, there's no data in here. It is just posts with an ID of 1. As I said, really basic and relatively familiar. If you have a collection, then you can wrap stuff in an array, and you basically have an array of JavaScript objects, and they have 1s and 2s. And so that works like that, basically. Not super freaking complicated. Yeah. Okay, more interesting things. We also support the ability to use links. And we recommend in general that you use links. There's certain things that's kind of out of the scope of this like introduction to talk about why you'd use links versus IDs. But basically what you can think about is a URL is a globally unique ID. So like post ID 1 on my blog is different than post ID 1 on your blog. But steveklabnik.com/blog/1 is a different ID than yourblog.com/post/1. So URLs are IDs, and therefore we encourage their usage in general. So we have an href that you can use, and this is also a collection. This is a different way of representing a collection. You can use an href with a bunch of comments after the end and just show their IDs, and then you have to give them a type if you do this like array style of things. One of the things that we did with JSON API was have the ability to side load stuff. I'll show you that in a second, but you can like lazily load the data if you want. So you can return a response like this that just has ID numbers, and then when they actually request a certain ID number, fetch it all, and you don't have to do it all at once. Or you can choose if you do want to like load it all up. So yeah, let's skip down a bit here. Blah, 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 blah. One of the things that we do that's interesting for formats is that we say what kind of HTTP responses you should make in certain situations. So we'll say like you should be using put, or you should be using patch, or you should be using post, which is kind of interesting too. So we have HTTP semantics as well as the actual structure of the JSON, which allows us to do things like this is how you create a new thing by posting to the URL that's located in this part. Relationships. So this is where stuff starts to go sideways often when you're arguing about things if you don't fully think things through, right? So in this case, if we have an author with a bunch of comments, or if we have a post with an author and a bunch of comments, you know, there's just a singular author 9 for the author, and then this list of comment IDs for the comments. But as I mentioned before, like fetching these things in a naive sense means that you make a bazillion freaking network requests. And so we actually have the ability with too many relationships that if you want, we'll talk about post IDs in a second, you can actually denormalize, so these compound documents. So for example, here's an example of a bigger, like more real looking response. So this is a bunch of blog posts. You might imagine this is like the home page of your blog where you want to show 5 blog posts and then like the comments that are associated with them. We actually now, because we did that namespacing earlier, we can split out the posts into one part of the keys and then the comments that are linked down from here. So what ends up happening is you have these posts, ID, titles, and then links. So links is the namespace that we use to represent the other associated resources, basically. So this post has 2 links to its author and its comments. And inside the linked, we can show that the person with ID 9 is D2H, the fictional person we made up, and then all of these comments that are located down here. The cool thing about doing this by using the IDs this way as opposed to expanding it, naively, if you just put all of the data from the author into each thing, you would get these duplicated responses. And if you have more complicated, where like multiple like polymorphic relationships, where multiple kinds of things can link to the same thing and all that stuff, it gets really hairy really quickly. So we thought about all that bullshit so you don't have to. And so we have the ability to like display them broken out from each other. So like things like the namespacing and all that other stuff gives you this ability to do this. The other thing we tried to build off of I shouldn't say as many others. It's a wrong thing to say we built off as many other specs as possible because that would indicate we were trying to maximize the number of specs. where existing work had already been done, we used the existing work rather than making up our own stuff. So for example, there's a URL template spec. I don't know if you guys are familiar with that. And so what ends up happening is that we actually say that the author, you can find the URL of the author by using this href and substituting the post author ID in there. To find a comment on the post, here's the href and posts and comments. And so these can actually be expanded out into their URLs to tell you where to fetch the resource from without having to repeat example.com/whatever a bazillion freaking times and bloating your response. So this is another example of like using a different spec to build on the kind of stuff that we're working on. We talk a little bit about stuff. JSON API technically does not make any restrictions on your URL namespace whatsoever. This is also one of the reasons why we prefer embedding URLs into your responses, is you do not have to follow the standard Rails naming patterns to do things. But we basically suggest that if you don't care, in the interest of not bike shedding, if you don't have a specific reason to use a weird URL structure, just freaking do what Rails wants to do and then just, you know, do something else instead with your time. And so we have like fetching stuff. Filters, so if you want to fetch all the posts by an author, you can pass in stuff and a compliant server will return the things filtered by that way. Includes, so for example, you can choose, like your app can choose at runtime that, you know, oh hey, I know I'm going to be displaying the text of all the comments for this blog post, so please include, normally I do not want to include the text of all the comments in every post, but in this case I do, so please give them to me. And you can add that kind of stuff and it will side load the response. This should all be familiar with you as that general technique, but like, you know, we built it into the spec. Sparse field sets, so if you want to ignore certain kinds of fields or only return certain stuff, we figured out how to do that. We have sorting in here, and you know, that kind of stuff. And then just general other CRUD junk with like, you should post to this URL to create a new resource, and this is what the response looks like, and this is what should come back, and like all of these details. Now, this is all super cool and fine and fun and stuff for us nerds that love HTTP and love spec documents, but I don't actually expect all of you to like go memorize this thing, although it would make me very happy if you all did, because I love spec documents. But the real power of defining something like this, and this is like another one of those big kind of insight sort of things, is the reason that you make an interface, like why you choose to make an interface and then publish it and make it public, is that other people can swap out implementations or they can build tooling around that interface. So for example, the reason that RSS was so freaking cool before Google killed it, because they suck, was that because it defined an interface for fetching things from somewhere, you built one RSS client, and then it could understand how to read RSS on your website and your website and your website and your website before we all used RSS and before it died. And so by writing one RSS parser and one RSS generator, you now enabled tons of clients and tons of servers to not have to re-implement all that bullshit again. So I actually don't expect that you all will memorize these details. What I expect is that we have these, we have a bunch of different like implementations, server side and client side so far. And this is always improving as new people build new stuff. But basically, the real benefit of everyone standardizing on a format is we can start reusing tooling and not need to rewrite generation and parsing stuff ever again. Because like, that's one of the most trivial, boring things to do in programming is like, how do I generate this JSON from this thing? I'm going to go write a bunch of code. Right? I don't want to do that. I just want to install a gem and tell it like, here's my post. Go freaking make some JSON. I don't care. And so if we standardize on these things and we start to share these kinds of responses, I won't need to rebuild a parser for every freaking website that comes out. I can just use the JSON API parser to get the basics down, and then 85% of my work will be done for me. And by me, I mean you all as like programmers, right? So we can save ourselves a ton of work if we all just agree to use the same shit instead of like making all these different choices that are irrelevant between all of our APIs. So that's kind of the broader vision in general. And as the spec finally is like almost finished, people are starting to write more implementations. So to suggest that the history of Ember data is complicated is like the understatement of the universe, right? But I just heard recently that the Ember data JSON API adapter is like getting better and does work most of the time and etc. Tomorrow, Yeah, it has tests and stuff. We are redoing active model serializers in the Rails world again. I'm making a post tomorrow about this. If you Ruby people are interested, tomorrow. So basically, the problem with AMS is that several people in a row said, I'm going to go do it. And so like I went, cool, I'm not going to worry about this because so-and-so has got the ball. And then like 6 months later, I hear from people like, is this abandoned? Nothing's happened in 6 months. And I'm like, this person told me they were going to do it. And they just didn't. So I'm finally sort of getting back into actually maintaining that stuff. And I'm looking for co-maintainers to help kickstart AMS so that the server-side story of this for Ruby should get like significantly better really quickly, hopefully. Yeah. So... yeah, claps and pull requests. Because I'm busy. But yes, so with that kind of work, we can just like do it once and then use it and never have to worry about doing it all over again all the freaking time. So that's sort of that. Yeah, you can use this in all sorts of other junk and things. I think that's pretty much all I have to say. So thank you for listening to me explain a bunch of stuff. I don't know if we have question time or not, but we probably do, so...
Questions for Steve? Start with Steph.
Ask me anything. Although if it's on topic, other people will probably prefer that. So.
Hello?
Hey.
Can you hear me?
Uh-huh.
All right. So for filters and various other GET requests,
yes.
There's a limit to the request size. And basically anyone that starts down that path and then lets stuff get generated by code immediately runs into that barrier. Is there something that JSON API has an opinion on?
So this has been mentioned. What's interesting about this is that this is one of those things where the spec and the real world differ, right? So technically there is not a limit, but Internet Explorer and a bunch of other things have like a 2048 character limit. And so in that case, I don't remember if it's actually codified into the spec or not, but basically you should just use freaking posts and be done with it. But I don't remember if that's actually built in. I think there's like an open issue to maybe explicitly say something about that. But yeah, I mean, I have never run into the situation where I'm filtering 2,000 characters worth of things, but I also, you know, teach, not do. So, you know, everything happens. But yeah, I would say that's where it is currently.
Cool. Yeah, if you're using UUID identifiers, you can get there pretty quickly.
Right, yeah. If you're going to use like really freaking giant long identifiers, then. But since URLs are unique, UUIDs aren't necessary. Trollolol.
Hey. Can you talk about the relationship of JSON API and REST and how patch plays into that? Because patch begins to take us away from REST a little bit.
Oh, God, you said REST. Okay, so I'm assuming you mean like Rails REST, not like actual REST? Which REST do you mean?
The one that tells you how to design APIs and use CRUD?
Yeah, okay, so not the real REST. Which is cool, I just want to make sure I know what you mean. That was like bespoke created by Rails anyway, so patch doesn't really take you away from doing CRUD, it just like replaces the update with a thing that's actually updating. So I don't think that it's taking away from REST in any particular way. The thing I mentioned offhand about the unified verse of like patch things is just that we basically say you should make a post request to this URL with this data. That concept does map to an equivalent patch response on a theoretical document that would be your entire API. So there's this like underlying concept of if everything your API could ever respond to is in one giant freaking JSON document, every operation we do can be matched to a JSON patch, HTTP patch request against that giant document, but I don't expect you to be serving your entire database on every request. So it's more about conceptual purity and catching weird edge cases than it is about like you should always use patch for everything. We recommend you use patch for updating because that's the HTTP method you were supposed to use to update stuff. Yeah. So this is still very cruddy in general, although not limited to CRUD.
Hey, so we actually decided to rewrite like a huge piece of our application in Ember about 2 months ago, and we're just finishing that up right now. We decided to go with JSON API, and it is amazing. Like, I don't know why this didn't exist earlier, so thank you for that. It has been just an absolute godsend.
That offsets like 100 comments about like, you must think that you are you named it JSON API? What kind of asshole are you? So
yeah, so it's been great. It's really been great for I guess just like an interface with Ember. I noticed that the Ember data the Ember data adapter for JSON API is only beta 3 compatible. We have a beta 8 compatible version that will be hopefully open sourcing early next week. So
sweet.
And we also have the active model serializer stuff done and good to go. So we should.
It sounds like we should talk a lot.
Yeah. One question though, is there any room in the spec for essentially circular references for like essentially arbitrarily nested documents or resources?
Yeah, so, oh god, so many discussions. I believe that it's like a denormalization issue, right? So you can say, if you have posts 1 and 2 and they refer to each other, you just put post in 1 and 2, and then you put a link, and post 2 has a link to post 1, and post 1 has a link to post 2, and that should be okay in that particular thing?
Yeah, like the linking is fine. It's just when you specify that as an include parameter, like what does that format look like? Is that just going to be like post.star, or?
I don't remember off the top of my head, so if it's not in there, we should at least clarify that it's not in there yet. So here's one of the things I didn't mention is that this also is not intended to cover every situation ever right in this moment. I am a really weird person in that I love backwards compatibility. It's like almost a not Ruby thing. So once we say the spec is 1.0, I intend for it to be backwards compatible forever. And that backwards compatibility means that you can add stuff. You can't just take stuff away. So what I'd like to do in this kind of situation is like mark that we have not, this is not in the spec yet, but that doesn't mean it never will be. It means that we can always add things. So I would be interested in at least documenting if that's a problem. So cool. I don't know off the top of my head, but we should definitely talk about it because that makes sense to me that that's an issue.
So I feel like the JSON API specification definition itself could be the subject, the target of a lot of bike shedding pressure itself.
Oh yeah.
So, and you talked a bit about this, but I wanted to know a little more when you were answering the last question. What would be the threshold of need, the level of requirement that you'd be looking for changes to be made for the next version of the specification after you reach your first final, of course?
So I guess really when you're making these kinds of things, there's always this tension between like making everyone agree and like being a ruthless dictator. So the trick to killing bike shedding discussions is to know when to like hold them and when to fold them, to use a terrible analogy. I've been really into terrible analogies lately. And so like oftentimes what it comes down to is if there's a compelling reason to add or change something, like if you can demonstrate like there is a problem with this. So for example, that comment we just had is like there's a situation where we may have these circular references, what do? And it's like, oh, that makes sense. This is a totally unspecified question. Then that's like totally, that is a very good like burden of proof in terms of like there is a weakness in this spec somewhere. Things like naming or structure in terms of preference. If there's a difference between like I mean, ultimately everything is really subjective, but like there are certain things that are more subjective than others. And so like if you're trying to change the way that something is named, that probably is irrelevant. If there is like, I cannot represent this concept in the spec, then that's definitely a really good candidate for like adding something. So I would say like demonstrating a weakness and how your change fixes that weakness is much more likely to get a like thumbs up than like, you guys suck and I prefer this, so I'm out, which happens a lot. You'd be surprised.
So you know a JavaScript person, so I can say this. I've been spending some time with the Media.js community. Don't throw rocks at me. And one of the things they do is they do use WebSockets as a persistent connection, and then they have some model called DDP that does all that stuff.
Sure.
How do you think this JSON API and the semantic and the structure and the argument that you and YCats have could be used if we were to build a more Ember data friendly WebSocket implementation doing similar things as what the media is doing between the server? How can this spec as a building block help make that happen?
I hate WebSockets, so I totally don't care about that question. That doesn't mean that it's not a good question. No, I mean this in the sense that like I have literally no idea because I think WebSockets is stupid. Because you're like rebuilding a TCP socket over HTTP on a TCP socket. Like if you want WebSockets, like use freaking TCP. I understand why it exists. I'm secretly like a really old man inside. Like I'm like, you darn kids, like, whenever someone first showed me Go and they're like, check it out, you don't need to define the interfaces, I was like, OCaml had structural subtyping 20 years ago, this is boring, next. Like, I'm actually a super old man. And so, yeah, that guy says. No, no. I guess all I mean is that because I don't know enough about, because I don't use that stuff, I choose not to have I don't know about it, I guess what I'm saying. I'm making an agnostic answer. It might be amazing, it might be terrible. He says it's probably amazing, so you should probably listen to him. But I don't know the answer to that question.
All right, one more question.
If you like WebSockets, that's cool. I just don't. It's fine.
Can you talk a little bit about hypermedia APIs and how they relate to JSON API?
Sure. So a critical person might suggest that I am using the JSON API spec as a means of advancing my evil agenda, pro hypermedia agenda on everyone. Whatever. No, it is not. JSON API enables hypermedia stuff, and we sort of recommend it because there are advantages, but it does not require it. So you don't actually need to put a link anywhere in your response if you don't want to, if that makes you feel ugly or bad or gross or something. But I like URLs. Actually, the reason that I think Ember is wonderful is because of its focus on URLs. And I think that a lot of people who come from other JavaScript framework backgrounds don't understand or appreciate how much those of us that again, this is my old man moment, is that like I tend to hate single page applications that aren't written in Ember because they don't behave like a normal application, and Ember applications behave like a regular freaking web page, so I tend to love them. And so that love of URLs and links and stuff carries over into my API responses, so there is definitely a relationship, and it is an attempt to show you some of the benefits of making those things happen, but it's not strictly required to use the spec. First of all, because you may disagree with me, and secondly, because it's easier to transition an existing API to the JSON API format without URLs and then like add them in later. So it's like originally when we had the dual-minded spec of like IDs and links, it was intended that you would like turn your API into the ID style and then turn your ID style into the link style. So it was like a transition path towards this idea. So that's sort of the relationship, I guess, is that it's like encouraged but not required if you hate everything I have to say.
All right, let's give Steve a big hand.
Thank you.
Hi, I'm Ed. Some of you may have seen me give the very first version of this talk at EmberConf. Some others of you may have seen the second iteration at Wicked Good Ember. Don't worry, you won't be bored. Things have progressed quite far since even that last talk. So what I'm going to talk about today is animations in Ember, trying to come up with good, community consensus and stop, again, bike shedding on all the possible ways you can solve this problem and try to come up with one good one that works for everybody. So when we talk about why you would even want to put animations in your application, right? We're actually not talking about that thing I put on the screen, right? That's just funny and cool eye candy. But if you actually had to stare at that for like 60 seconds every day while your app loaded because it was slow, you would hate that hamster, right? So this isn't about that kind of animation, right? We've had that kind of animation for a long time. Yeah. Oh, Flux is on? Thanks. Good call. See, I don't know it's on because, woo! because I'm so used to it. Yeah, so we've had lame animation on the web for a long, long time, and that's not what I'm talking about, right? I'm really talking about animation as a physical metaphor, right? In computing, we are completely overloaded with physical metaphors because we can't even think about computing without talking about windows and folders and all these things that don't really exist, right? They're all just completely metaphorical, but we as human beings who have primitive monkey brains don't really have ways to relate to the abstract things that go on in computing, so we need physical metaphors. And so animation is actually one of the really key physical metaphors that we can use to make our computing feel like things that human beings can relate to, right? So, as an example, right, if you do something like scroll around on an iOS or on your phone, there's momentum, right? Momentum is a physical concept. It's not something intrinsic to this computing environment. It's actually obviously a lot of work to add momentum to something like this that doesn't have any momentum. But it tweaks that little spot right in your brain that knows how the physical world is supposed to behave, and it hijacks it, and it helps you understand how this computing environment works, right? That's the promise of having smooth animation in an application. It's a major win for usability. It's one of the key reasons iOS was such a revolutionary thing, because it really took advantage of that to make it that much friendlier for a normal human being to relate to the computing environment. iOS was often called skeuomorphic, right? And that just means that it's a new medium that is copying a lot of features from other older mediums that don't even necessarily apply anymore, but you keep them there to keep things comfortable. And the classic examples of that are all of the textures and the shadows and things like that. And iOS has moved away from that, and the whole global design trend has moved away from that, and flat UIs are in. And so one way you see that is, skeuomorphism is out. We're not going to be physical, we're going to be this abstract computing thing. But I would actually argue that the key piece of skeuomorphism is still there, and it's the behaviors, it's not the appearances, right? So when navigation moves you from place to place and things come and go in an animated way, right? All of that is a skeuomorphic metaphor, right? The views don't really come and go anywhere. They just appear and disappear. But we use these metaphors to talk about them. So I'm gonna start by giving a couple of little examples. Oh, so by the way, I should give you a little more context here. So on my title slide here, I have some links. This presentation is an Ember application, and its source is linked here. And there's also links here to the Liquidfire library itself and its docs are also an Ember application. So it's Ember all the way down. If there's anything you see that looks cool, you can always go see the source and see how it works. And I just tweeted out the link, so at Ember NYC. So I'm going to start by giving a couple of little examples of the kind of things that you want to do in your app and the kind of ways we can do them. So I'm starting with this because this is really the simplest case. And this is the case where you've got data bound into your template and it's changing for whatever reason, and you want it to change smoothly so that people are aware of that change, right? So this is the simple case. There's no routes involved. There's just simple views. Okay. The way you could do this kind of thing with the library I just wrote, Liquidfire, looks like this. So a theme you're going to see here is that there's a lot of template helpers that are intended to be very conceptual drop-in replacements for the native Ember template helpers. And so bind is something that is a normal Ember helper. It's actually one you almost never have to use by name, because when you just have no helper at all and you just have a bare value, it's actually doing bind. So liquid bind does the same thing. All it does is take our value and bind it live into the template. The difference being that liquid bind is going to be animatable. And so you can see 3 liquid binds here for my hours, minutes, and seconds. And then I have this other helper, liquid width. Now that's just like Ember's regular width. Except that context that it's providing, it's going to hold on to it and let you smoothly transition from an old context to a new context when the bindings update. And the reason I'm using a width on this last one here is because I actually want to have some template context inside of my animated environment, because I want another div, and I want the class on that div to actually match that bound mood value, because I'm coloring all the moods differently, right? That's why sleepy is one color and happy is another color, right? Those are just CSS rules that are bound against that class. Next example to get you interested. So this one is actually showing a fairly low-level primitive. The idea here is that I have live bindings that are measuring the height of an element, and they're providing it as a binding to the rest of Ember so that you can do dynamic things with that height no matter what changes it. So in this case, you see there's the red lines surrounding my imaginary web post here. And so as my post changes, the measurement on the farthest right, that's constantly measuring the distance between those two things. By itself, it's very simple, but that becomes a primitive we can use to build much more fluid interfaces that are going to grow and shrink dynamically as the content evolves. And the way that helper looks, that one's called liquid measure. You can see it's a helper right here in this template. All it's doing is introducing a new element there that has a height property that you can bind to. And when I say height equals story height, I'm not setting the height of this thing, I'm reading it out. Remember, these bindings flow in both directions. And so I'm able to bind story height into the template below, and that's why you see that size in pixels. So we use this primitive to build more sophisticated elements. So here's an example where as I add elements to my form grows smoothly, and it shrinks smoothly. Okay. So this is done with a liquid box, which looks like this. Liquid box is, again, it's just introducing an element, but this is an element that's going to smoothly grow and shrink as its content changes. So all you have to do is the normal Ember thing, push a new contact onto the context list or pop it off, and that box is going to grow and shrink for you, and you can just drop this in. Both the liquid box and the liquid measure that came before it actually support multiple different ways of measuring the size of the thing inside. By default, it's simply going to measure itself, which is what's going on here. But you can also use it to measure things like absolutely positioned children, which let you get around some of the real quirks in CSS animation. Right? A lot of times the thing you want to animate needs to be absolutely positioned, so it's hard to keep it in the document flow if you want its height to still be fluid. Liquid box can solve that problem by always watching the height of its absolutely positioned children and growing and shrinking its own height, either instantly or animated, to match them. So the next example is going to use that. So here's a form, and when we change the first value, we transition smoothly to the other state. You can see that there's actually two animations going on here when I change this. The first one is that the whole form itself is growing and shrinking, and the document flow is adapting. So my yay, let's go button moves up and down, right? Because the form takes more or less space. The other transition is that the content of that form itself is actually cross-fading, where the old stuff is fading, it fades out, and the new stuff fades in. So this is a combination of two helpers. We have a liquid box around it, just like in the previous example, so that it can grow and shrink dynamically. And inside of that, we have liquid if, and liquid if is just a conceptual drop-in replacement for Ember's normal if, except that it is animatable, and it has, and because it's animatable, it is introducing an extra layer of a div, right? The normal Ember if and things like if and with and outlet, they don't add any divs, right? They're completely virtual views. In these cases, we do deliberately add those divs because those are the things that you're going to hold on to and animate. So you can also add a class to them like you do here, because there is a div, we can put a class on it. And so I think the template reads pretty clearly like an Ember template should, except that we have this nice transition. Now, the next question would be, how do we decide what animation is going to apply to this liquid if, right? Liquid if doesn't just do what I showed. It's actually a very general purpose thing that simply gives you the hooks to decide to animate between the two states. How you animate between them is a separate question that really doesn't always belong at the view layer. And so one of the architectural decisions in Liquidfire is that the conceptual decision of what transition to do at any given time is really not in the general case a view layer concern. It can be non-local. It could be something, especially when we get to some of the later examples where you're transitioning from route to route, it can be very conceptual at a high level of your application. So the convention here is that just like you have an app/router.js in an Ember CLI app that defines your route map, with Liquidfire you have an app/transitions.js, and it defines your series of transition rules. So we're going to take a look at a bunch of those rules. The first one here is actually the rule that goes with the example I just showed. And so this is a transition rule that matches an animated element that has the class vehicles. And only when I'm transitioning from a non-empty model, I'm going to use this animation called crossfade. So non-empty model here is there because if it wasn't, we would actually animate this on the very first render when you first visit this page. That counts as a potential transition too. That's a transition from the empty state to this element being there and having a state. If you want to target that, you can. So you can target different transitions at the first render versus other subsequent changes. In this case, I didn't want any render, so I made my rule more restrictive, and I said from non-empty model. That's a shorthand. I'll show you some more examples that are the more general ones, and then we'll take a look at the docs, which explain all of this. Crossfade here is the name of an animation. That's one of the ones that's built in right now. That is all completely adaptable to how you want to define your animations, and we'll take a quick look at that as well. So my next example here moves on to something that it was historically much, much harder to do in Ember. And this is when I actually listened today to my EmberConf talk. It was the first time I did this topic. And when I got to this part, I said, and this is the stuff that's really hard, and there's no good solution yet, and I hope it gets a lot better. I think it will. And I could say today it got a lot better. So here I have a list view, and it has details that you can animate to and go back to. And this is a real route transition. If you look at the URL, it's adapting. I can actually go to a detail and then hit the back button, and it'll take me back natively, right? This is just a normal Ember route transition. And the template for that is literally liquid outlet. That's it, right? And I write transition rules. Thank you. So in this case, there's actually two different transition rules because I'm using two different animations. And they read pretty straightforward, right? If I'm going from index to detail, slide the thing to the left. If I'm going from detail to index, slide the thing to the right. So this is an example of using constraints on the routes themselves, both the source and destination routes, to determine which transitions I'm going to run. Right? So this language for writing your transition map is all about a series of constraints. In any given rule, they all have to match. And if they match, we would use that animation. And we're going to go through the transition map and find the first one that matches, and we're going to use that animation. Next example is slightly more sophisticated riff on the same idea. So in this case, I'm on a detail view of a particular model, a person number one. And if I say increment, it slides to the right. And if I say decrement, it slides to the left. Okay? Now this is a case where I'm not going route to route anymore, right? I'm actually going from model to model on the same route. Now, outlets are not involved in that kind of behavior. If you know how Ember normally works, right? In a case like this, if you just go from person 1 to person 2 on some person route, the router doesn't even get involved. It gets involved, but it doesn't change any of the outlet stuff. The views that were already there stay stable, which is nice, because that's a performance optimization. Only thing that happens is that the model switches out on you, right? So in a case like that, a liquid outlet's not what you want to animate. In this case, this is one of the cases where you would use the liquid width. So when I say liquid width model, I'm creating a new context inside that is going to hold on to that model and be really lazy about letting go of it, so that when you switch models, we still have that old one ready to go and still rendered, so that you can gracefully transition between the two and have both rendered at the same time. Right? So that logic is built into the liquid width itself. It's going to have memory and hold on to the context that was bound there before, so that the two are actually in the document side by side, and you have the luxury of switching between them however it is you want to. And so in the case of like a 2 left, 2 right, they're both in the document and they're just both sliding. And we can show some of the other examples. So the transition rules in this case are showing that we can actually decide which animation to run based on the properties of the models themselves. So the last example we looked at was looking at constraining a rule based on the routes. In this case, we're constraining it based on the models, right? So I write a rule that says, if I'm going from a model that's an instance of a person to a higher person, go to the left. But if I'm going to a lower person, go to the right. Right? So if I go, increment, it's going to go to one direction, and decrement, it's going to go the other. That all remains true, even if I change the URL. So if I go from 2 to 20, it'll go to one side. If I go from 20 to 2, it'll go to the other side. Right? It's using the rules, looking at the models, deciding what transition to run. Thank you. And so you can imagine now how to combine these two kinds of constraints between both routes and models to do arbitrarily deep and nested things. Right? You can go from a person's page to that person's detail page, and then click on some related person and go to their page. And all of those transitions can follow have some logical layout in space. And that's really a high-level concept in your application. That's what motivated me to break these rules out as a separate thing that lives in the separate map, the same way that your routes live in a separate map. And one question I've been asked already it's a potentially interesting idea that we haven't explored yet is whether this kind of conceptual mapping actually could go emerged into the broader mapping DSL. And that's a possibility, although it doesn't really map one-to-one. So it's something we're thinking about. Right now it's a separate DSL, and I could show you some more of it. So that's the source we just saw. Oh, and my last little example here is a modal. Now this one actually, I could say actually doesn't actually use the liquid-fire library at all. This is just a little technique that is a nice one that takes advantage of query params. And I throw it in here because modals are something people ask about and there's a lot of opinions about. And this is something you can actually do quite nicely already with Ember as it is, as long as you have query params. And the trick is very simple. It's that there is a named outlet way up at somewhere high in your review hierarchy, probably on your application route or however high you want to go. And it's got it's watching a query param, and if that query param is there, it's going to render itself and it's going to come over the page. So when I click on this, you'll see I'm actually updating the URL. I've got a query param that says modal demo true. I can dismiss it with the back button because it's just a URL, and it's actually truly modal because I could be on some other page, right? And oh no, I can't type with this microphone. Right. So if I just add that parameter anywhere, I get my modal, and I could dismiss it again. So that wraps up my little run-through demos to get you excited about what it can do. I'm going to jump next to the documentation on this library and how it works, and just give you a high-level map of how this documentation is laid out, so that you can dive in and really get to try it out and help me hone this thing to be an API that we could call 1.0. So in terms of the maturity of this, the techniques are ones I've been using a long time in my own applications and have really honed through experience. But in terms of the API design and what's going to be most natural for people, there's a lot of conversation yet to happen, and I'd love to have those conversations. I'd love to have people trying it out and bringing the edge cases to our attention, so we could move this thing toward a stable API. I'll say that it's definitely not a stable API yet. We still want to make these APIs better. But that said, it's totally worth using in your app. It just means before you upgrade Liquid Fire, go make sure it still works, right? So this talks about some of the key ideas and things I already showed you. So let me jump straight into the next page, which is the list of helpers, right? And we talked about, I think, all of these already. This is what they are, right? Outlet, with, bind, if, measure, box. And then each of them has a page and an interactive demo that shows how they work. And this is very much like the one I showed you before. And so that's the outlet. Here's the with, right? With has its own little demo here. And there's there's snippets of the transition map and the template to go together to kind of explain how it works. Oh, and by the way, so I mentioned that these docs are themselves an Ember app. I also publish an Ember CLI add-on that does code snippeting, where you can actually comment up your own application source and it can display itself. I like that. Honestly, I only did it because I knew if I didn't, I would let the two diverge. So this is better. So we talked about liquid bind, and here's a very similar example. So when I showed liquid bind, I didn't actually show rules about how I made it transition. Here I'm actually showing one of the rules. So in this case, I'm targeting my transition based on a pattern of the DOM, right? So I'm saying this transition applies to child of liquid bind demo dib. So that's another way to target these kind of things. You can target based on the route, the model, or their context in the DOM. Let's see. Liquid if. Here we have another little demo. This one is doing a crossfade to this content. And has more examples. So there are, in terms of just caveats to think about. One of the things I mentioned is you can do matching by model, and in the case of a liquid if, it's not obvious what the model is. It's actually the predicate itself, the thing that is true or false. And so you can write your rule so that it will go do a different thing when it goes from false to true than when it goes from true to false, right? And you can also do the different thing when it goes from empty to true on that first render, or empty to false. Those can also all be matched. Whereas the other ones bind with outlet. The model is fairly what you'd think it would be, right? An outlet has a model for the route. It's the one the router gives it. A width has the model of whatever thing you bound into the width. All right. So liquid measure we talked about does this pixel stuff. Whoa. I guess we have really long precision on those pixels here. I didn't realize that. And the liquid box. So liquid box is, I mentioned it already. The things that will, just to draw your attention to, is that you can measure the content differently. There's a couple different things you can measure, and that's documented back on the liquid measure itself because that's what it uses. This self, biggest child, last child. These are some of the methods it can use to measure its content. This is an area, again, where the API really kind of needs some more people to look at it than just me and see what makes sense for the most people in the most situations. Last child, in particular, maybe should be the default here. And the reason for that is the way these animations are actually implemented, right? So if you have an example like the one we just saw where you have this one, there's a box on the outside with an if inside, right? And so when the if changes and it swaps out its content, we want the box to grow and shrink based on that content. And so what you really want is to kick off an animation that's going to grow you from your current size to the size of the new thing that's coming in. Not the size of both of them together, even though they're both in the DOM together. So that's why you would have a rule like last child. And it's last child because the new view is always appended after the view that was already there. So the transition map is what ties all these rules together that I mentioned. I don't actually have a good story yet for how to use this in apps that are not Ember CLI apps. That's like a high priority open issue. The two things, not important, that's right. Steph says it's not important. I kind of agree, except I actually myself have an app that's not Ember CLI app that I should probably make it work for. And actually I do want that to work. We just need to put in a little tooling work to make a build and come up with some conventions for how to stuff your transition map in here. So at the very highest level, the transition map is just a bunch of this transition statements. It also can take define statements, which are the ones that actually determine what does crossfade mean, what does to left mean, what does explode in sparkly stars mean. You can make whatever animations you want, and those come from the define statement. So this is how you match by routes. There's kind of illustrated by example here the things you can do. So all of these constraints they're all anded together to make a real match. So if you only say to route and you don't say from route, it'll work from any route, including the empty one. The matchers can be route names, but they can also take a function that'll just do anything to that route name and decide what to do with it. From route null is what you use to match the empty route. Within route is just shorthand for saying from one route to itself, meaning the route's not changing, I'm just inside this route. Matching by model, we talked about. This actually is where we document what is the model for each of these helpers. And then you can say from model to model between models. Those all apply the constraints on one side or the other or both. And some of these we saw already, like instance of match. You can also just take a generic function that will, it will get this as the model and it'll just decide, is this, oh, that's missing a return, isn't it? I need to fix that. You can see I've been polluted by some CoffeeScript. I am moving on to ES6 too, but yeah, return is not implied, is it? Here's an example where we're actually applying two different constraints on the source model. So both of these have to be true. They will be checked in order. So first we say, is this an instance of person? If it is their age over 21? Then we will go to the left. So let's see, between. I didn't mention yet, although I had it briefly in one of the examples, how to do direct comparisons between models. And so a constraint on the to model also gets the from model as an argument if you want to look at it, and vice versa. And as I mentioned, there's this shorthands for from non-empty model to non-empty model between non-empty models, because that's a fairly common pattern when you want to exclude that empty case. So again, these are all subject to lots of feedback from the community as people begin to use this. And you know, APIs really can't be good until they're really used in the real world and people generate feedback. And the last section here on matching is DOM constraints. So this is where you can match things like has class on the animated element. And this is a good place to point out that pretty much all of these can take classes, both static strings as classes and bound names as classes, and that works. And this is one of the little areas where these helpers differ from the stock ones, because the stock ones tend to be virtual and don't have any element at all, and these do, because sometimes you really want that, or usually you really want that. And you can also say child of, so that lets you match based on your parent element's selector matching. And the one caveat on child of is that due to the way handlebars works, being purely stringy and not knowing anything about its actual DOM context, the child of cannot match at the very first render because it's all just strings at that point. And so when good old HTML vars rolls along, and well, Metal Views can already do this, then we will be able to actually make this match all the time. And that's a good transition to say this doesn't all work on the Metal Views branch yet for those cutting edge people here who are using that, but it should and it will. And around the time that goes to Ember Canary, we will make sure this works in both libraries, and I would in both models, and I would intend to make sure it's going to work under both for the duration where we need to transition. And lastly, this is where my documentation runs out, and there's still some holes left. I'm giving an example of how transitions are defined, and so there is a promise-based API here that gives you composable primitives for putting together the kind of steps you might want to do. So when you define an animation, you're giving it a function that gets a reference to the old view, which may be null if this is the very first render. There is no old view. You get a function called insert new view that will return a promise for the new view once it's been inserted in the DOM. And you can take options, and options lets you do things like, in your transition rule, say, do a crossfade but make the duration of this one longer, or make this one go, a different direction. Right? It lets you parameterize these things. From the what? Oh yes, yes, and actually that's something I think, was it you and I who talked about that? Somebody I talked to this week also gave me that idea, which is a great idea, which is to pull these transitions from the container so that add-ons can throw new transitions in there. That's a fantastic idea. We should definitely do. Right now it doesn't. Right now they're all just internal to the library, but that's an easy thing to add. That's a good idea. And then we can have an add-on ecosystem of beautiful animations. So the primitives here, that stop and animate, are both coming out of the library, Liquidfire. So when I say stop old view, that's just saying if it's already moving, stop that. Right? Don't wait for it to finish, just stop it. Then we're going to insert the new view. Once it's inserted, we're going to animate the old view's opacity down to 0 and the new view's opacity to 1, starting at 0. And this part here is actually a very thin wrapper around Velocity.js, which is the underlying animation driver library that I'm using here. And so, like the documentation for can I say opacity and why does it take a 1 and a 0, that's all just passed straight through to Velocity. Animate exists mostly to handle a bunch of the edge cases around making sure that it's returning promises and views are going to get cleaned up afterward and things like that. So in this case, crossfade here is animating the old view and new view at the same time, and inserting the new view at the beginning. But because you have the control over when the new view gets inserted, we could also write one where we're going to fade out the old one first, then insert the new one, then fade in the new one. Right? So just by moving around the code here in this promise-based implementation, we get the full range of possible effects. So that is the whole tour. So as you can see, I still have some little black links on the side here. These are the pieces of the documentation that I intend to write and haven't yet. But it's quite a good start. I think it's definitely ready for people to try to use it. I love to hear feedback, and I want to see what you guys build, and I hope it's really awesome, and I think it will be. So thank you.
Awesome. We've got time for a couple of questions. I'm going to run this guy over.
When a user hits the back button multiple times, do you queue up the animation or cut to the last one? Or is that a hook for the user to do something?
Right. So that's a good question. So right now, most of that's actually up to the individual animations. That's why this one says stop. It wouldn't necessarily have to. It could decide to let that old animation run and then do its thing. This one is just going to stop it where it was. Now this is not always what you want, So I do intend for this part where you define animations to be smart enough to know how to do it either way. It does mean that in practice, if you want to make really bulletproof ones, they're going to get a little richer than what you see here. For example, when you're going to do like sliding left to right, if you're halfway transitioned and the user changes their mind and goes back the other way, you really want that to do the logical thing and just like, oh, I was sliding, I'm going to start sliding back, right? The tricky piece is that Ember has already forsaken the old view at that point, right? It's going to give you a wholly new one that looks just like the old one. But your animation still could actually look at where the positions of all the old ones were and say, oh, it was actually only halfway, so I'm not going to make it go the full distance. I'm going to start it on top of that old one and actually make it look seamless. So that should all still be possible to do. And I think that's probably a good argument for why the animations themselves may be great things to build it as part of the add-on ecosystem, because I think making ones that work in all those little corner cases really well is an art and is a little tricky. And so my goal is to make the API here rich enough to do that, so that the animations themselves can manage these issues.
One quick question: what is the what platforms does this work on? What platforms are supported?
Yeah, so this will work on anything that Velocity works on, which is actually pretty wide. It's not so it takes advantage of hardware acceleration when it can and thinks it should, particularly on mobile devices where that's really almost always a win. And it's actually also but it's also doing pure JavaScript request animation frame based stuff where it can as well. And that can be, it's not always obvious which is faster in different situations, and the Velocity people are very focused on optimizing all that, and it was one reason I went with them. And also their API is pretty good. And so I look at what Velocity supports, and that's what this supports.
So I was wondering about you were going through everything, I was wondering about the future-proof type bits of this library, and you answered one of them with the HTML bars and how that works and how it's tied to the current rendering. But then also with the dependency on Velocity and the upcoming like HTML animate property, and how, I guess, are you just going to depend on Velocity to cover that type of fallback if browsers start supporting that, or are you going to look into it yourself?
Right. So so almost everything I showed you really is very agnostic to how the animations themselves work inside. In fact, this implementation that we're looking at right now that takes an old view and insert new view and this stuff, animate here is a function that's provided by the library, but you're not required to use that, right? You can plug in here any function that will take those DOM elements off the views and move them around, right? So I think this is actually nicely separable from the problem of how do you actually do the animations themselves, the driver for that. And I'll also add, so that's the nice thing about it. It's nicely separable. The flip side of that is that one of the things this library doesn't solve for you, and you still need to know about how animation in CSS works and like what needs to be absolutely positioned and what needs a relatively positioned container and things like that, because those issues are, CSS is unfortunately the tool we have to solve those problems, and I don't want to try to redefine CSS in this library. So I think that my goal for the APIs here is to provide, we really only manipulate the styles where there's only like one obvious right answer, and the rest of the time, you, the designer and programmer, have to come up with the styles that are going to work for your layout. So we're kind of agnostic to that stuff, and for good and for bad.
2 more questions.
This is amazing. I think we're all really happy about this.
Thank you.
This is like what I dreamt Ember would be like when I first got started. So
Awesome.
this is
Awesome.
great.
Thank
you. And so I'm gonna be like the downer here, or the, the critical person. I saw a bit of like domain logic, so, the if age.
Yeah.
Part. What is the philosophy on mixing those concerns?
Right.
You know?
Right. So the idea here is that the transition map is very much domain logic. It's very analogous to your routes. It's where you're mapping out your own application, and so something like looking at your models and deciding how they physically relate to each other is I think it's very appropriate that that's model related logic, right? Because conceptually, deciding that this route is to the left of this route, or is behind that route, or is the flip side of that route or that model, right? Or that this person is to the right of that person. Those are very abstract things in your model domain, and that I think all that concern belongs in the transition map itself, and that so these things about like what is a crossfade, what does to the left mean, those are much more view-oriented things, and I do think that they kind of belong off in a library that's going to plug them in so that the transition map can talk to them. That's how I see the architectural split.
All right, last question.
When the animations are starting and finishing, are there any like callback hooks so that you can hook into that and do anything custom outside of the context of defining your own animation?
No, and so the answer there is that you should really compose animations, and that they are composable. So, you'd want to, if there was something special you wanted to do after this crossfade, you would write your own function that calls the crossfade, and then it returns a promise, and when that promise resolves, you would do your thing, and then that would be a newly composed animation. So, it's intentional that I'm favoring composition here over like injecting hooks.
Cool. All right, join me in saying amazing to the editors.
Thank you.
All right, next month, the fourth Thursday in August, check the meetup site. We've got Alex Machnier is going to be presenting on React from an Ember developer's perspective, which should be very interesting. Thank you all for coming out to the July Ember NYC mini conference, apparently. That was quite an amazing set of talks tonight. Thank you to all of our speakers. We are going out for a drink or two to Lily's on 17th Street between...